Alright guys, so this video is going to be about 8.3, graphing quadratic functions. The essential question is, how do you graph a quadratic function in the form y equals ax squared plus bx plus c? Make sure you note that this is standard form. We have talked about that in the last few videos as well. So understanding standard form is pretty important for this unit. You might want to pause the video to get all this written down. I'm going to keep moving pretty quickly, but feel free to pause or replay any parts. Alright, so there's a couple general steps that you're going to see me do every time in order to graph a quadratic function. We're going to find the axis of symmetry, use that to find the vertex. This is from 8.2, right? Find the y-intercept, and find two more points on different sides of the axis of symmetry. So basically, steps 1, 2, and 4 are going to be creating the table of values. So if you remember back to 8.1, when I made the table of values with you and I gave you the x values, in this lesson you're going to use this information to figure out your own x values. So make sure you write all these steps down. Alright, so let's go ahead and move to our first example. So, before you worry about sketching a graph, let's figure out our table of values so we figure out how many spaces to make our graph. So write down this first quadratic equation, y equals x squared minus 4x minus 5. So our first step is going to be to find the axis of symmetry. So I'm going to follow these steps almost exactly. So step 1, we're going to find the axis of symmetry, which is negative b over 2a. So get in the habit of writing what a, b, and c are every time when you have a quadratic. So a is 1 because that coefficient of x squared is 1. b is negative 4, and c is negative 5. So now when we find our axis of symmetry, negative from the formula, b is negative 4, and 2 times a, which is 1. And then we'll clean this up. So a negative 4 turns to positive over 2 times 1 is 2. 4 divided by 2 is 2. So I'm going to abbreviate this. Axis of symmetry is x equals 2. Now we're going to find our vertex. Think back to the previous lesson, 8.2, we found the vertex by plugging in the axis of symmetry. So every x value is going to get replaced with 2. Alright, 2 to the second power, 4. 2 times 4 is 8. And then going left to right. 4 minus 8 is negative 4, minus 5 is negative 9. So your vertex is the x value 2 and the y value negative 9. Alright, so take a second and make sure you've gotten all that written down. Alright, so if you notice, I have done step 1 and 2, axis of symmetry and vertex. Then it says find the y-intercept. Maybe go back to this step and make a note that the y-intercept is always 0, c. 0 because it's a y-intercept, so it has no x value, and c, so whatever that constant is. So our constant here is negative 5. So we're going to do 0, negative 5. You can make a note to help yourself remember that that was the c value that I used to make my y-intercept. So I've got a lot of information here. I've got axis of symmetry, vertex, y-intercept. Now it says use a table of values, and we're going to find 2 more points on different sides of the axis of symmetry. So I'm going to come down here and make a table of values. It's important to remember that the axis of symmetry or the vertex is sort of in the middle of that graph. So you're always going to see me put this vertex in the middle of your table of values. Because that last step said to pick 2 points on different sides of the axis of symmetry, which is this x value of 2. So what is one value smaller than 2? 1. And what is one value larger than 2? 3. So you might want to use your calculator to do this calculation. I'm going to do it pretty quickly over here. So y equals, so I'm going to plug 1 in. I definitely recommend using your calculator, but be careful with your parentheses and plugging in. So now it's going to be, okay, 1, so it's going to be 1 squared minus 4 times 1 minus 5. Just plugging in my input to get an output. 1 squared is 1 minus 4 times 1 is 4 minus 5. Negative 3, negative 5, it's negative 8. All right. Now we're going to plug in 3. Y equals, so I'm just replacing these x values with 3. 3 squared minus 4 times 3 minus 5. So 3 squared is 9. 4 times 3 is 12 minus 5. So we have 9 minus 12 is negative 3 minus 5 is negative 8. So notice this value repeats. That's something we're going to talk about later, but when you're going around this axis of symmetry or this vertex, you will notice a pattern about repeating values on either side of that. At this point, you could add in your y-intercept to this table of values, and it works nicely with this one. It doesn't always, but now we've got a good table of values. So now when you're graphing, or you're about to draw your graph, you might want to think about what x and y values you need. So in this graph, we appear to need only positive x values and negative y values. So giving yourself a large fourth quadrant picture. All right, so 0, negative 5 is going to be a y-intercept, so it's on the y-axis. 1, 2, 3, 4, 5. Remember, it's 0, 5, so 0, I never went anywhere on my x. 1, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm just plotting these ordered pairs. Now I'm going to plot 2, negative 9. 2 on the x. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then 3, negative 8. So it's going to be right there. And remember, this is your vertex. This is where that axis of symmetry is, so it makes sense that these points are symmetrical. And then you can just connect, making a nice parabolic arc or a parabola. And then sometimes it's helpful to sketch the axis of symmetry, which is at the x value 2, to just show that you have drawn an accurate quadratic. And that's exactly these 4 steps that we follow. Feel free to rewind or rewatch any part of this video, because now we're going to move on to example 2.